Okay, good afternoon, everyone. Let's get started. Sorry for running a little bit late. Oh, by the way, our course by default is streamed to the YouTube channel. So, I think we have mentioned that in the last lecture, right? That's why every time when we start, we need to spend a few seconds or minutes to set up the streaming setting of the video lecture, right? So let's continue with the course syllabus. So we talk about the grading policy at the end of last lecture. So basically, the work for this course has two components. One big components. One is homework. The other is a course project. And I'm reading all those instructions explained to you, but if you feel anything unclear, if you have any question, please raise your hand and ask. Don't hesitate. Okay. So homework part, it takes 60% of the final weight. That means we're gonna weight it as like 60%. So it's very, very important. We plan for 6 homeworks. So maybe I'm saying homework 0 has been released, right? So if you haven't seen that, please double check with the Canvas. We actually released on Tuesday. We highly suggest you to start working on it now, because it's due on next Friday. The reason of this is we want to help you to quickly review those fundamental things you do need to know to take this class. At the same time, by doing this homework 0, you can check whether you really like this kind of taste or this kind of style. If you're really sick of it or you're pissed off by those problems, then next Friday is the end time for you to switch the course or drop this class, right? So you can make decision at that time. That's why we released homework 0 and set the deadline to be next Friday, right? And also our TA office hour will start from next week. If you have any question, so just come to stop by the office hour. We got every weekday, we got office hours. You can also post questions on cameras. And we got 2 TAs. They're gonna watch the cameras and trying to answer questions as soon as possible. Okay. So so what kind of home problems will be, right? So we usually have 2 parts. One part is about analytical problems, and the other part is about programming assignments. But in this course, we don't have too much programming assignments, at least not as much as machine learning entry-level class, which I taught last semester. So maybe you will see like until the 3rd homework assignment or 4th homework assignment, you will see the programming assignment. But that does not mean like the programming task is a trivial or straightforward. You still need to spend some time to do that. Don't try to rush at the last minute, right? So the analytical problems usually are designed to check if you really understand what you have discussed in the class, right? So they have some like analytical questions, ask you to derive something, to show something, to calculate something. Right? This is just like math problems you have taken in like linear algebra or calculus. Right? And then the programming assignments usually request you to implement particularly probabilistic learning models. Like I want to ask you to implement a Bayesian linear regression with some kind of Gaussian basis, right? So we ask you to implement posterior distribution estimation and show them, draw a plot to show how the posterior distribution contract along with more and more training points are added. Right? Those are typical questions. We may also provide synthetic data or real-world data set where we're going to download them and process that for you, right? And then you're in charge of implementing the models and collect the results and show them as we request in the homework assignments, right? So each homework assignment might have a different number of points, right? It's depending on the workload. Maybe some homework assignment, the workload is light, some is a little bit heavier. We cannot guarantee like a uniform workload. But I will give some hint, like if we feel like, oh, this time the homework assignment maybe contains too many problems, we will give you some warning message to encourage you to start early, right? But in whatever case, please do not start doing that like at the last day or trying to rush for them like with 2 hours. According to my past experience, it won't work. It won't work and make you feel like frustrated, stressed, or even panic, or even like pissed off, right? So don't do that, right? So try to start them early and as early as possible, because in most time our office hours are empty. So always encouraging you guys to stop by the office hours. But if you want to help, if you only want to seek for help to the last day, which is usually Friday, then you might not be able to get enough help because so many students are in the queue, right? So please, like, trying to find some like time earlier than the deadline, especially Friday, and then it is much more easy for us to help you. Any question? Okay, great. And here we have some restriction on the programming language. We only allow the usage of MATLAB, Python, or R. The reason is simple. We don't want you to have too much work, coding load for that. So that means even you prefer to use C++ or use C or use like even assembly language, it's not allowed. Because if you use C++ or C to implement the matrix multiplication, that may take you 1 day, right? So don't waste your time. Right? If you use Python, if you NumPy library or MATLAB, it's just 1 line of code. Right? So please focus on the topic, the course topic, rather than some like low-level details. So that's why I highly encourage you to use these 3 type of program languages, because all kinds of like matrix operations, linear algorithms, and also optimization procedures have already been encoded in their default libraries. So you don't need to worry about that. Right? You only need to focus on the modeling part, the inference part, like the high level part, which is the major things we discuss in our class. Right? And in the later stage, we might have some programming tasks that ask you to use PyTorch or TensorFlow or JAX. I didn't put JAX here because JAX is quite new, but it becomes more and more popular. It has a trend that it's gonna like make TensorFlow to be discarded. To be and later, I guess, in the future, people will either use PyTorch or use JAX. But whatever, you can use PyTorch. PyTorch maybe it's the most friendly package where you can conduct deep learning Bayesian deep learning, all kinds of machine learning. You don't need to worry about the automatic. You don't want to worry about how to compute the gradient, all kinds of stuff. Right? And also, it's very easy to debug. Right? However, we will now teach you how to use PyTorch or TensorFlow or JAX. That will leave you some self-teaching task. Right? If you have never used the PyTorch before, and the program assignment happened to ask you to implement some, say, Bayesian deep learning inference with PyTorch, then you have to spend some time to look at documentation about PyTorch, play with that, and get to know how to call them and create your neural network. This is your own task. This is reasonable because it's a grad level course, and you're supposed to be able to self-teach you something, right? But if you still feel like it's really difficult, you need some help, please do not hesitate and stop by the office hour. Right? So during your implementation, right, you're free to use existing libraries like NumPy, SciPy, or Tensor library in PyTorch or TensorFlow or JAX to finish basic linear algebra and optimization functions. Like, unless the homework say, okay, you cannot directly use them, but in most cases, you should be able to use them by default, right? However, you're not allowed to use existing APIs to create the model we want you to implement. For example, we might ask you to implement a logistic regression, okay? So for Bayesian logistic regression, we know that many packages like scikit-learn or even some third-party library for PyTorch, they contains the implementation of such models. Then if you want to implement them, you may just call one line of the code, like call one line of the API, like create an object which is a class for the logistic regression. That's not allowed. Right? You can only use that to do some kind of tedious matrix computation, matrix inverse, log determinant, gradient calculation, all those kind of stuff. But for the model level, you cannot directly use them. Right? We'll check the implementation of the homework assignments. We will not only like just run your code or look at the report. We'll also check the code. Any question regarding the homework assignments? Everyone feels good? No question? Okay, perfect. Yeah, then let's talk about the second component, big component for this course, right? Which is the project, right? So we want you to do a course project to deepen your understanding of the topics we discussed in the class, and also to give you some chance to practice those things, right? So you can either use probabilistic learning techniques to address one research or practical problems of your own interest. For example, if you feel like using some probabilistic learning techniques can help with your research project, suppose you're a PhD student or you're a master student doing some RA job, right? Feel free to do so. We're very happy to see that. Right? There's a good chance like to advance your research and to utilize this resource of this course, right? Or you can also choose to read 3 recent papers in the umbrella of probabilistic learning. Right? Those papers must be published in top machine learning venues and should be no later than 2005. If it's before 2005, it is a little bit too old, right? And here we provide some venues like NeuralNIPS, ICML, AISTATS, ICRR, UAI, all kinds of stuff, right? And then you need to write some summary of those papers to show that you really have understood those papers. You can point out the pros and cons of those methods. You can give critical thinking. you can talk about if you want to improve upon that work, what are you going to do? Okay. So if you're doing a research project, you need to create a GitHub repository and then submit your midterm and the final reports. Okay. So we don't want you to submit too long reports. So please do not exceed 6 pages for each report. So the report should include like what you have done, what is the problem formulation, what is the current results, what's your plan for the next step. Okay. And if you're doing paper reading, you don't need to create any GitHub repository, but you need to submit one paper summary before the midterm and 2 other paper summaries before the final. Okay. And the summary, as I just said, like should describe the content of this paper and what kind of problem, what kind of method they're taking, what kind of experiments they have done, what is the advantage, what is the shortcomings, and if you want to continue with this line of work, what are you planning to do, right? And the summary of each paper should be at least 2 pages. Right? That means your summary shouldn't be too short. If it is too short, it's skeptical that you're not really reading through that paper carefully. If the summary is less than 2 pages, unfortunately, they will not give you any credit. So you must ensure that your summary is at least 2 pages. And also, you cannot copy sentences from the original paper. That means you cannot copy a paragraph of the paper as a summary of that. That's not all. You must write down your own understanding of that paper. Okay, I'm gonna go dive into the details of this course project in our course website. Before that, any question? Yeah, feel free to ask any question. Okay. So now we're gonna jump to this course project web page in our course website. Like as we mentioned, like if you go to our course website, and you can see a few tabs here, right? And let us first take a close look at this project page, right? So let me enlarge the font, right? So it's basically give a more detailed information about the requirement of course projects, especially the grading standard, than those listed in the syllabus, right? So first, let us talk about the reading project, right? As we just mentioned, you can select 3 recently published probabilistic learning papers to read, right? And you need to make sure that you fully capture the idea of the paper, and then you can write down some summaries as the report. Right? And this project must be done individually. That means you cannot form a group to read 3 papers. That's not fair to guys who are doing like research project, right? So those papers must be published in top machine learning conferences. Here's a list of conferences which we view as top tier, like NeurIPS, ISML, AISTATS, UAI, and SAR. Right? We give the links to those conference website. You can see the proceedings of those conferences every year. You can pick out whatever paper you want to read, right? You can also choose to read journal papers. But this is usually much more challenging because journal paper is usually much longer than a conference paper. A journal paper could be like 50 pages long. Right? If you do want to do that, feel free to do so. Right here, we list the venues, the top venues regarding journal venues regarding the probabilistic learning, like Journal of Machine Learning Research, Transaction of Pattern Recognition and Machine Learning. JASA is JASA Annals of Statistics, and GRSB. These are 3 top statistical journals. And also the Bayesian analysis is a very famous journal, which focuses on Bayesian learning. Okay, any question regarding the reading project? Okay. So then let us talk about the grading standard, right? So basically, we're gonna have 3 milestones for the reading project. First, you need to tell us which 3 papers you want to read. Okay. So shortly, we're gonna give some announcement or some assignment, which are about paper choice, right? So in the paper choice, you should notify the instructors the papers you want to read. Okay. You can just upload a PDF, at least the paper titles you want to read. Through the paper titles, or perhaps our TA will just search that paper, look at the abstract or introduction to check if they are really probabilistic learning topic, right? It must have some something to do with the probabilistic learning. If it's completely irrelevant to probabilistic learning, then it's not allowed. Right? You need to at least you need to select some related topic to our class. But other than that, the paper choice is really flexible, and even like as the semester proceeds, like in past years, I've seen the cases like in the middle or even in toward the end of the semester, some student ask me if they can replace their paper choice with other papers. That's fine. If you want to do that, it's fine. Okay. But I'll still suggest you, like, because you need to spend quite an amount of time reading through those papers, it's better for you to look at them and make a decision early. Okay. And then in the middle of this semester, you will be requested to submit a midterm report, which summarizes 1 paper. Then at the end of this semester, you are required to submit a final report, which summarizes the remaining 2 papers. All those milestones will release some kind of summons and some notice so that you know when is the deadline to submit those reports. So what's the requirement of the summary, right? Here's a detailed requirement. We want to check and see if your paper summary contains the following sections. Okay? And each section has different number of points. Okay? So you need to first give a brief introduction to the background and the motivation of the paper, right? So you can say, okay, this paper is trying to generate some images according to text, right? Generate some interesting images according to text. And why do they do this work? Because this is very important, and this has a lot of like entertaining or commercial applications. And the current methods has these issues and that issues and cannot be useful in those scenarios. That's why they propose a new method of doing that. And what kind of method do they use? Okay, they create a markup chain and to gradually corrupt the pictures or images and then gradually recover them in reverse markup chain, something like that, right? At least you use a few sentences to point to the key techniques or key novelties of the paper, right? And then you talk about, okay, they have conducted some experiments on some benchmark data set, compare with a bunch of CDAL parameters, showing some advantages and examples, right? So this is about the first section, right? And then second section, you need to give the formulation of the problem, right? The formulation is really not like, okay, they want to do matrix factorization, right? And you need to give some like abstract symbols to denote those stuffs, right? For example, this paper is doing symbolic regression. That means they want to learn some function from the data, but they do not know the symbolic expression of this function. So by giving that data like x1, y1, x2, y2, those pairs of training input and outputs, they expect to return a function with some meaningful and succinct expressions such as f of x equals to e to the power of x plus sine x plus cosine 2x, something like that. Right? You need to give a kind of like formal definition of the problem. So people when see this formulation, they won't get confused. They will exactly know what this paper is doing. Right? And third one, talk about the technique contributions. Right? So basically, you need to list every critical steps of their models and algorithms. You don't need to write down all the mathematical details about their method, but you do need to list the case step of their method. For example, what is their K model design? Do they introduce a normal, a different prior distribution, or they introduce a different framework, or introduce a different laws, and so on. Right? And in the algorithm design, what kind of case steps so that they can accelerate, they can make the results more accurate, they can improve the they can get rid of the previous problems, the corner cases, that kind of stuff. You should explicitly state things like that, so that when our TAs read your report, they basically know what kind of methods this paper invented to address the problems of interest. Okay. And then evaluation part. How does this paper conduct evaluation? How does this paper demonstrates that their idea is working? Right? So typically, you're going to list, okay, they test their methods in task 1, task 2, task 3, right? And for each task, for task 1, they use the benchmark data sets like ImageNet, like CIFAR10, like whatever, right? And then they use they use the mean square error or root mean square error to measure the performance, right? And then they compare with a bunch of state of R's like convolutional neural network, like UNet, like ResNet, all kind of stuff, right? Or like Gaussian process, like Bayesian logistic regression, those kind of stuff, right? And how do they conduct experiments? Like they do 5-fold cross-validation, and they use like held out validation data sets with 50,000 examples, right? And tested it on the tested sets with 10,000 examples, right? And then what is their error, prediction error accuracy with standard deviation shows that they're working better than that. Right? You should give a pretty concrete evaluation step in the paper. And based on their evaluation results, what kind of conclusions did they draw? Usually they will say, okay, so our method is much better than the other methods. Our method outperforms the benchmark or competing methods by a large margin or statistically significant, right? And sometimes their conclusion might be wrong, and it is you have the chance to correct them in your report. And finally, we ask you to do some kind of critical thinking. Right? No paper is perfect. Right? Actually, nowadays, because it's a fierce competition in the area of machine learning, right? Everyone tries to hide their every paper tries to hide their deficiency, right? And right now, those top tier conferences like NeuralNIPS, they kind of encourage you to write down the limitation of the current work. Right? I don't know if this is really useful, but if it happens that those papers do not explicitly talk about their limitations or deficiencies, and you can think about that. Right? So there's always shortcomings of some work, and if you can find it, then it will motivate you to produce another paper. That's how we advance the research area. Okay, basically, we want to look at the the 1, 2, 3, 5 sections, your paper summary. So if you lose one section, you're going to lose the corresponding portion of the points. So be sure that your summary has the structure which contains all those five sections. It's even better, like you can use a small title on each section, like brief introduction, write several paragraphs, and then problem formulation, several paragraphs, technique contributions, several paragraphs, and so on. Right? That will make our TA workload much easier. Okay, any question regarding the grading standard about the paper rating project? Everyone's comfortable? Okay, that's great. Oh, by the way, here I want to emphasize that we want you to really understand those papers, right? So that means we do not accept too short summaries, right? So that means we have some lower bound of the summaries length. It cannot be less than 2 full pages. Right? If it's 1.5 pages or 1 pages, then unfortunately we won't give you any credit. Right? And second thing is also very important. You cannot copy sentences from the original paper. I don't do that. If we find such sentences, the summary will not receive credit as well. Right? And there's something I should mention that actually the camera system has upgraded, and it's getting stronger now. It kind of like catch everything or every solutions, previous solutions, all kinds of stuff. So if there is some kind of potential plagiarism or warning, they're gonna automatically pop up. So don't try to copy the sentences because once you have told us what kind of papers you're gonna read, we'll put them in the library. We'll put them in. You will upload them to a Canvas system. So if you upload your summary, they're gonna do some automatic matching. Right? If there's some sentences are the same, they're gonna give us some warning. So it's not good to do that. Does it make sense? Okay, now let us proceed to the second type of project, research project. I personally am more passionate about this. Right? So you can use probabilistic learning approach to explore some research tasks or address some research tasks. So don't worry if you feel like, okay, you're trying, doesn't work. It doesn't matter. It doesn't matter at all. The key is that you have used those techniques to try. So we won't deduct your points if your experimental results are not good. That's not our standard. Right? So the project group, you can form a team on that, but at most 2 students per group. Right? So you can find some partner, you two together to do the project. Right? And similar to the machine learning course, right? So our grading and milestones have this 3 steps, right? So first, you need to tell us what is project team, right? Again, you just notify the instructor, the members of your project group. We kind of like maybe next week or the week after next week, we're going to release some assignment which asks you to tell us, like upload one PDF or Word document, like saying, okay, what kind of project I want to choose. If I'm doing a rating project, what are the 3 papers I want to rate? If I'm doing research project, what is my project teammates? Right? Or you can do the solo project by yourself, solo fine. Right? And then in the middle of the semester, we request you to submit a midterm report. So the midterm report is restricted to be 5 pages, right? Describing what you have done so far for a project, right? Here are the several sections we expect to see from your midterm project report. Right? So first, please briefly introduce to us the problems you want to solve using probabilistic learning technique. Right? So give some kind of problems description, problem formulation. Then tell us, why do you want to use probabilistic learning techniques? Right? Why don't you use the traditional methods or existing methods in your own field? Right? For example, if you want to use probabilistic learning to solve partial differential equations, then you're going to tell me why don't you use final element? Why don't you use final difference? Right? What's the benefit of this probabilistic learning technique? You should explain. Right? And then what you have done to reach your goal, right? The section 3. Right? And it's not like, okay, we just collect data. That's not enough. At least you have done some simple basic trials or tests during the middle of the in the middle of this semester. Right? And then what's your next plan for the rest of the project? Here you should list some details, like for example, I tried that, I use simple Bayesian linear regression, it doesn't work, right? But it gives some meaningful results. So I feel like, okay, I'm gonna use some Bayesian nonlinear regression like a Gaussian processes or Bayesian neural network. We believe that will help largely improve the prediction accuracy or largely improve your probabilistic solvers of your problems. So then that is good, right? Then you need to give us some design of your nonlinear regression or probabilistic or Bayesian neural networks, right? For example, I want to create a 3-level neural networks. I want to use ReLU or use 10H activation functions. I want to use Hamiltonian Monte Carlo sampling to do the posterior inference rather than variational inference, because HMC, the Hamiltonian Monte Carlo sampling is more is less biased and converges to true posterior, all kinds of things like that, right? And finally, reference to the literature. This is just to enforce you to obey the standard in scientific literature, right? Every time you write something, you write paper, you write technical report, you want to exchange your ideas to your professional fellows, you have to obey some kind of standard format. You have to give the reference and to acknowledge others, other professionals' credits. So this is about midterm report, and then how when we at the end of the semester, we wanted to submit the final report, right? And this final report will request the length of report is not larger than 6 pages, right? So this is the size should be 11 font. Don't be too small, right? This final project report should be structured as a small research paper, right? And this here are the 4 sections we want to see, right? First, what is the problem definition and the motivation? So you should give some kind of formal definition of the problem you want to solve and what is motivation of that. So to write such kind of section, typically you'll say, okay, here is my problem. I want to learn some symbolic expressions from data, and the current methods always use I don't know, like evolution algorithms, search for that, or what other heuristic searching algorithm for that, and they do not kind of uncertainty quantification, because many parameters in your learned function are not known as well. So want to jointly estimate the symbolic expressions and also unknown parameters like some physical properties of the materials. And then how can I do that? So you should give something like that. And then the second big section, talk about your solution, right? You can write down your models. You can write down what is the hierarchical design of your Bayesian models or recurrent neural networks or some policy gradient learning approaches, all kinds of stuff, right? And how you want to develop that, right? For example, I developed it with I implemented the algorithm with PyTorch, and there's a key step for the stochastic optimization, which I use the reparameterization trick, all those things, right? So basically, your solution should give us a hint that give us the impression that, okay, I can just follow what you wrote, I can replicate your work. Okay. This is also the requirement for research papers. And third big section is the experimental evaluation, right? So like what you have a rate for other papers, from other papers, like you have to choose the tasks or data set you want to evaluate your development method, right? And you have to select several baseline methods or competing methods to show that, okay, your invention really works and it's better than the existing method, right? And then you need to clarify what kind of experimental setting you choose, right? You want to do 5 cross validation to choose all the hyperparameters of your model, and for the competing baselines, you test it. You calculated the mean standard deviation error and also standard the mean square error and the standard deviation error. You compare with all of them, and you can show the tables or you can show the figures, and which can demonstrate that your method is better, right? And finally, you should briefly mention your future plan, right? Although you do not really necessary to do things you plan, right? But as a standard for the technical papers or research papers, people will expect to see that, okay, if you will continue onto this work on next step you're going to do, right? If you want to do the theoretical projects, that's totally fine. Like if you want to show some, if you want to prove some convergence or error rate of your newly developed or novel algorithms, right? You want to show that if you want to use deep neural networks to approximate polynomials, what is the asymptotic bound, right? You can do that totally, right? And then in that case, we're gonna grade your solution experimental part altogether with 40 points in total, because a theoretical project won't ask you to do some like real world applications and experiments. So any questions so far? Okay, so if you have taken my machine learning class before, all those might sound kind of like familiar to you or even a little boring, but please bear with me, because I have to tell those students who haven't taken my previous class before, right? So last, your final project should include a GitHub repository that links your implementation of project. Right? So that means we'll check your implementation, your code as well, to ensure that, okay, this is indeed your implementation. It's not the report, just is not fabricated, right? It's real, something real. Right? Someone asked what kind of projects you want to use, right? Someone will say, okay, I think it's cool, but I don't know. There are a lot of cool tasks. I don't know which task is appropriate as my course project. Right? So here we list a bunch of examples, right? So like you can do some application project, right? For example, recently the image generation task is very hot, right? You can try to leverage existing libraries like DAL2 or the Stable Diffusion. All those are all like probabilistic learning packages and trying to finish some particular tasks, right? That's okay. You can try to reproduce some published results, right? There are some crises in the computer science community. It's called reproducibility crisis, right? Some papers are not replicable, right? So if you can try to replicate or reproduce the results published some papers and pointed out, okay, if it is really consistent with what is reported in the paper, or you cannot replicate them, both are really useful and valuable. You can do the theoretical project as we just talk about. You can do some algorithm project, like you want to develop a new learning algorithm for a particular type problem. Say, if I feel like, oh, if I'm sick of like backpropagation algorithm, I want to have a novel way of training neural network. I want to kill backpropagation. Feel free to develop new algorithm. That will be if you succeed, well, it's an honor of my class. Right? You can also do your own research. This is for, yeah. If your research happens to be related to this, you want to apply some possible technique to that. That's totally good. Yeah. So in general, choose topics that you feel exciting and convince me that the topic is important or interesting. So if you're kind of like unclear, you're still like weighing in balance, you're not sure, feel free to stop by my office hour, and we can discuss. Or you can chat with our TAs because they're doing probabilistic learning for quite a while. They can give you useful suggestions. Some kind of examples, right? You can click into the Kaggle computation platforms, right? So there are like a lot of like machine learning tasks and a lot of data, right? And contains a lot of interesting problems, right? You can pick out whatever you feel interesting, or you can even like use their data and formulate your own problem. There are some like concrete examples like biology and medical study. Like can you select genes relative to breast cancers, Alzheimer's disease, right? Commodity recommendation. There are a lot of like recommendation data sets in Netflix data set, movie lens data set. You can investigate this data set and say if you can do some personalized recommendation, right? And software security. Can you predict if Android app is malicious or not, right? You can do sentimental analysis, like you can see if this piece of Twitter comments or tweets are kind of like contains hatred information or not, right? Or you want to detect the false information or misinformation propagating the social networks. Those are all hot topics in data science. Like spam email detection is kind of like a classical topic. Okay, so any question regarding the details or requirement for the research project? No question? Okay. Mm-hmm.
Yeah, regarding the summary-based project, so we just have to grab the idea of all those 3 papers and actually put a summary of 2 or 6 pages and submit that to the deadline.
Yes, you don't need to do any programming.
Yeah.
You're replicating the results. That's not required. Yeah, I mean, if you consider research project, well, you can consider pick up one paper, read through it, and implement their method and examine the results. That is called research project, although it is not really research. But I will say it's an important step of research because many researchers is motivated by replicating other stuff's methods. Any other question?
For the research project, do we have sort of like a vetting process where to kind of evaluate if what we want to work on is a decent enough topic for this course? Like, do we have a good enough data set, or is
No, we won't do that. You can, of course, what you want to do must be within the probabilistic learning framework, right? You cannot say, okay, I want to do SVM. I want to use SVM to do something, right? That's not probabilistic learning, right? But of course, if you want to probabilistic kernel regression, kernel classification, that's totally acceptable. We won't check like if your data set is good quality or valid enough. That's not, as long as your project is related to probabilistic learning, that is acceptable.
When working in groups, do we submit our reports individually, submit a report as a group, are they graded?
Individually, please. The reason is that the TA wants to grade your report one by one. If you do not submit individually, although I know the content will be identical, that's totally fine. Because we'll check if there's some warning message pop up in the system, we'll check if you are in a group, that's totally fine. We don't care about that. But if you miss that, you might just miss grading your part. We've met a few cases before. So of course we can remedy that issues, but that will take some time. Like for example, if the final grade has already been submitted to the administration department, then if you want to update your grade, and then it will take a while. So that's why we ask everyone to, even you're working as a group, submit this project by yourself. Any other question? Okay, perfect. Okay, so then let us go back to the syllabus. We're gonna wrap it up. Okay, final exam. We don't have final exam. We don't have middle exam, so you don't need to worry about okay, what kind of final exam problems you need to prepare. Right? The most important things are homework and course project. If you your progress are doing well, you finish those things in time, and you will expect to get A- or A. Okay, so actually, we're quite generous in grading. Right? We're not picky, but we cannot give you points if you don't submit your assignment or report. Okay, so letter grade mapping, right? So finally, your numerical grade will be, oh, question.
So if there's no midterm or final, what do you mean by midterm and final for like deadlines?
We'll release some assignment in the cameras. Like it's kind of like in the middle, but we won't give you like exact date right now. But we'll release that and give the deadline and tell you, okay, this is midterm project report. It should be due by say March 20, something like that. Other question? Okay, great question. So we don't curve the grade, like we don't curve the numerical grade, and then we just round up your score if your score contains some digits, right, to the closest integer values, right? For example, if it is above 90.5, right, 9.5 to 90.9, we'll treat it as 91. If it is 90.1 to 90.4, which is truncated, right? So there's some late policy, right? We have some strict deadline. It's usually at 11:59 p.m. It's usually on Friday, right? So you should turn your assignment in through Canvas by the designated deadline, right, to receive the full credits, right? If you miss the deadline, you have first 10% penalty for the late submission. Then after that, every subsequent 24 hours, you will lose another 10% credit. For example, if you have a 10-point assignment, right, that means if you do the late submissions, it will first have 2 points deducted. Right? And if it's submitted 30 hours late, you have another 10% of penalty. Right? And if it is submitted after 48 hours, right, then we won't, there won't be any grade on that. I mean, so you cannot submit homework assignments 2 days later. And we'll post the assignments far enough ahead of time. So usually we won't make exceptions if you fall ill. But if you have some like emergency or you have some prolonged ills, you want to apply for personal extension, please send me an email. And also we want some notes. I want some either witness letters or doctor notes, and to prove that you are experiencing something different, right? We won't disclose that. We're just doing this just to be sure to be fair to everybody. Okay? Sometimes there's something we have experienced before, like quite a amount of students are asking for extension. If there are many students asking for extension, we will do consider extension. But if there's only 1 student, 2 students ask for extension, we cannot do that usually. Okay? So if you want extension, either you have some medical emergency or you have some other emergency, ask for personal extension, that is acceptable. Or like many students are asking for extension, then we'll consider that. if you believe there's some grading error in your homework assignments, please contact with me as soon as possible, right? We request that within 1 week of receiving your grade, you can request a regrading. And please send me an email first. Don't send them to TA. Send me and explicitly explaining why you think their grading is wrong. You should have like 5 more points, but they forgot. You should have some bonus points, but they forgot. And then I will forward your email to the TA and also CC to you so that TA can take a look at your explanation and give the response. Okay. So please try to ask regrading as soon as possible. Here we give some like strict window. It's 1 week, right? But I did see some cases like, okay, the final grade has already been uploaded, have been submitted to the registrar office. And then the student asked, okay, homework 4 or homework 5, you lose my bonus points. That's make us too hard to deal with, right? Although I try our best to help with you, but it's not wise to do that, right? Sometimes like because once the final grade has been submitted or uploaded to the administration, if you really want to change that grade, I should get approval from upper level. It's not like that. I say yes, it will yes. I also need to get approval from my department. So yeah, for your benefit, if you really care about your points, and please point out problems and request regrading as soon as possible. And here is letter mapping. So you can see that which kind of final numerical grade will be mapped to the letter grade. So it's really it's not very hard to get A minus. I remember in 1 year of this class, I think like 35 over 50 students got A or A minus. Right? Only a few B minus or C. Right? So that means if you really follow the progress of this course, you finish all the things in time, it's very likely you get A minus or A. Okay, any question regarding the grading standard and policies? Okay, so homework submission, right? So we only accept homework written with LaTeX. We unfortunately do not accept manually written assignments or Word document. Please use LaTeX. And how many of you have used LaTeX before? Okay, perfect. So for those who you have never used them before, don't worry. So it's really easy to use. And here we give some link to some sample LaTeX file. You can try to find some editor and try to compile that. And we highly encourage you to use Overleaf. This is an online LaTeX working platform. You don't need to buy anything. Just click into that and you write down your LaTeX file. You write down a LaTeX source in there, and you can compile it online and show everything. So that's why we highly suggest you to use Overleaf to finish your homework assignments. And every time when we release the homework, we'll give you the LaTeX source of the homework. So you can just copy paste to your Overleaf. Like in your Overleaf, you can create your own project and copy paste your the homework LaTeX source, compile it. It has already shown up, and then you just insert your own solutions, like some math stuff, some pictures, some PDFs, those kind of stuff. Right? So it's really convenient. So any question regarding the homework format and assignment format and the submission? Okay. And academic policy, I think this is pretty standard, right? Do not plagiarize others, do not cheating, all that kind of stuff, right? So those are all the links. Please respect those rules, right? And the collaboration policy, right? And if you're doing homework assignments, you're encouraged to discuss answers with your fellows, right? You can work together in a small conference room or your classroom. You can try to derive things all together, how to solve those problems. However, you must write down your code, your proofs, your derivations by yourself. Right? It is okay that you and your friends like reach agreement about how to solve that problem. You both think, okay, I should first prove this and then show that and calculate that. It's fine, but you should write down the whole procedure by yourself. In some special cases, which I rarely see, that if you expect the answers from you and your collaborator will be very similar, then you should explain explicitly in your homework submission, right? To what extent you have collaborated. Like you can, if you're like, okay, you and your friends are writing kind of very similar solution, like even in terms of sentences and symbols, right? Then you should write one paragraph in the front of the homework with LaTeX. Maybe you can quote it with blue color, saying, okay, I'm collaborating with John, and we think this problem can be solved in the same way, and we have very similar writing customs and styles. So our method, our submissions might appear to be the same, but don't get confused. We're not copying with each other. Right? I rarely see this, but I just put this in case, right? In case that will happen. Right? If your submission appears to be too similar to others, but you don't provide any explanation, then it's possible that you will receive 0 grade unless you give some reasonable explanation after math. So, any question? Okay. And finally, if you're feeling like if you have some physical challenging things, or feel free to let us know, right? And also contact the relevant department in the university to help you. And also, if you need some like accommodation, some help, please let me know. Okay. Any question regarding the syllabus and the cost policy? Right. We spent like quite a while to go through this, and in detail that might sound boring, but please bear with me. I want everyone to be clear about our schedule, about our expectation, and about our rules. Everyone's good? Okay, so now let us get back to the slides. So again, I want to put a little bit of warning message for this class. So this course overall is very math intensive. So in the following lectures, in subsequent lectures throughout the semester, you'll see a lot of mathematical symbols and the calculations and derivations. You'll see matrices, vectors everywhere. So if you feel sick of that, please seriously consider if you want to continue with that. Okay. And we also want you to have a certain level of programming skills, right? I mean, you cannot just be able to write hello world, right? It is better that you have a coding some math related or statistics related program before. You feel better, right? You won't write like 10,000 lines of code. That's not an engineering project. But you may be asked to implement different machine learning algorithms and models. It might contain like 100 lines of code. That's not lengthy, but you need to ensure that it is working. I give you a data set, you run it, and you read out the prediction, you look at predictive distribution, you look at the variance, you can show all the results are reasonable. That's very important because understanding the math details is different from implementing with your Python library, with your Python code. If you're difficult on that, if you feel like, oh, I have no clue about how to detecting the possible errors in my code, then you should seriously consider whether you're gonna take this class as well. So usually, if you how many of you are from CS department? Okay, most likely. Okay, if you are from CS department, you have received some training about programming. I think that will be fine. If you're from other departments, you've never done coding before, you should be careful. But I know someone, like some other students from other departments, like mechanical engineering, biomedical stuff, they're familiar. They're even more familiar with CS students in Python and MATLAB. In that case, you're totally good. I don't need to worry about that. But just I want to let you to pay attention. And the workload overall is heavy. It's expected like you're going to take 6 to 10 hours per week, but perhaps for many of you, only 6 hours will be more than sufficient. I'm giving the very pessimistic estimate of those time. If you take the class in time, interact with instructors, or you feel like no issue, understand all the course content, maybe you just need 2 hours or 3 hours per week. That's totally fine. But if you feel like very hard to follow what you have discussed in the class, or after class, you watch the video or look at lecture slides or look at the book, you feel like it's too difficult, then this course might not be a good fit to you. So how will you learn, right? We suggest that you take classes to follow the math, understand the models and algorithms, okay? And you should derive the math details by yourself, right? So we're gonna list those steps, right? Maybe I will do this hands-on stuff with you in the class, right? But after that, even if you feel like you understand those things, please try to replicate those things by yourself. Use your hands, write on papers, right? That will give you a really understanding or in-depth understanding of the content we discussed in the class. And finish the homework assignments to deepen understanding, implement and debug the models and algorithms by yourself, right? And further, you can do some course project to enlarge your vision and practice your capability in applying and probabilistic learning. So this course overall focuses on mathematical foundations, modeling and algorithm design in the probabilistic learning. So it is not to apply machine learning to some specific task like image tagging, autonomous driving, right? This is not like a pure application class, right? But I hope that after taking this class, you will be able to more easily to grab this from cutting edge research or tools to do all those fancy stuff, right? Unfortunately, this course focuses on fundamental things, that means all kind of abstract things. And we're not, we also are not gonna talk about the specific machine learning tools or libraries such as scikit-learn, PyTorch, JAX, all kind of stuff. You might be required to use them, but you are asked to learn them by yourself. We're happy to help you during office hour, but due to the tight schedule of our course content, we might not be able to open lectures, serious lectures covering that. Right? And also, we won't teach how to program and debug. Right? So we assume that if you understand some kind of algorithms, you should be able to implement and find out error by systematically debugging their code. Right? So this is an advanced course for students who want to study machine learning in depth or quickly get to the frontier research of probabilistic learning. So it's not a preliminary course. So the content might be hard for someone. So that's why we keep doing all those messages to encourage you to think about it carefully, not to listen, not to because this is course about machine learning, so I want to choose that. It might not be appropriate for you. So if you feel like following things, right, don't take this course. Like if you feel you're struggling with linear algebra, calculus, or basic statistical concepts, don't take this class. We'll assume that by default you understand the basic ideas of those things. Like, if you're sick of mathematical symbols, derivations, proofs, or calculations, maybe our class is not appropriate for you as well, right? And if you do not feel good in programming and debugging, you're not confident about your programming, right? If you write a piece of code, you're not sure it is working, it will work normally, then there can be some problem. So we assume that you're not scared about math, statistics, calculus, or calculations. Instead, you're happy with them. Then you are very appropriate. You're a good fit to this class, right? And you're comfortable with abstract symbols and matrices operations, right? So later you'll see that I will list a lot of things, like I will by default assume this is a vector, this is matrices, and I'm gonna combine them in all kinds of ways, right? And I write down all kinds of Greek letters, local stuff. If you're not feel sick of that, that's good. Right? If you feel sick of that, if you're pissed off by that, then that's not good. And you can pick up MATLAB, Python, R quickly, even if you have never used them before. Like I think if you have received like proper training for CS training, that won't be an issue. And Python's, MATLAB, R, those kind of things are relatively much easier than C++ or some other language. I think it's even easier than object programming. So if you're good with that, it's fine. Right? And you enjoy debugging, you enjoy step-by-step looking at, checking, investigation, print out, those kind of stuff. That would be very good, because that's how we, the machine learning researchers, are doing things every day. Right? I write a program, I often have some bugs. I have to find the problems, so I have to print out, I have to step in, I have to step out. And I often debug with my students. When I do some research projects, when students say, okay, professor, your idea doesn't work, and looks like it will fail, I'll say, I don't believe that. Show me the code. Explain me the code, and I will debug with you. I often do things like that. So if you are enjoying the debugging procedure, then this class won't be a big issue for you, right? And also, you can quickly learn how to use TensorFlow, PyTorch, or JAX, all those kind of machine learning packages. That is also good for this class, because this is also nowadays like how machine learning practitioners are doing things, right? And there are numerous like open source libraries based upon PyTorch, R, Julia, or JAX are released every day, right? You don't want to reinvent wheels, right? You want to leverage others, right? So if you can quickly hack into their code and leverage their code and plug into your own library, that's very, very good. Right? And most important, you haven't planned it for enough efforts for this class. This class might be, I mean, it depends on, it depends. Like some of you may feel like this is too simple. Some of you may feel it's too difficult. But you should prepare some enough efforts beforehand. Like you see, like say, okay, I only have a 1 hour every week to do this class. Then I will suggest you to not to do that. Like you should make some time preparation before. Like even later, you feel okay, this is so easy. I didn't need so much time of doing that. That's fine. Like that means you earn a lot of like extra time. You can use that to watch YouTube videos or doing whatever things you like. Right? Okay. So if you feel not right about any of those assumptions, please seriously consider whether to take this course. So I ask you guys to think about those questions, look at those hints we listed here, and also start doing homework 0, and then check to see whether you seriously want to take this class. So after all, we want you to succeed. Right? We don't want you to feel like, okay, you take this class and you get tortured, right? That's not what we want, right? We do want you to spend some reasonable amount of efforts, and then you feel like you really learn something, right? That's really why I feel interesting, I feel enthusiastic to teach. Right? I don't want to feel like, oh, you didn't receive anything and you got tortured. That's not what we want. Okay, any questions so far? And there's two links, my homepage and the course website. So feel free to click them and find a relatively relevant information from there. So okay, so let's stop here today. So we have spent like 2 classes to explain every details and policy of this course. So overall, it sounds a little bit boring, but please bear with me. We want everyone to get clear about this, the design of this course, and so that you will have a good starting and good progress through the semester. Okay, thanks everyone. So see you on next Tuesday. Hey,
About the office hour. I saw the website said the TA office hour is by Zoom.
oh, right now it's we're trying to schedule the TA rooms now.
Okay,
I haven't yet determined it.
so there will be an update.
Yeah, there will be update soon.
Okay.
Yeah. No problem.
Which is in civil engineering,
Okay.
and my supervisor wanted me to attend the immersion learning